Hello friends, let us discuss about aldol condensation. So as we all know that aldol condensation is a reaction of carbonyl compounds which have at least one alpha hydrogen. That means formaldehyde and benzaldehyde, they cannot undergo aldol condensation because they do not have alpha hydrogen. So as we all know, the reaction is if I take any aldehyde having at least one alpha H, so even this reaction can begin with ketone, aldehyde, anything. It should have at least one alpha H. So since this is the carbonyl group or carbonyl carbon, so the carbon adjacent to this are alpha carbon. So this aldehyde or ketone is having alpha carbon. Okay, so when 2 moles of these react in presence of a base, any base, like we can take NaOH or KOH, so it undergoes condensation, and the product, I'm directly writing the product, and I will tell you the mechanism also. So this is the product. This is called aldol, and then when it undergoes dehydration, means loss of water, so it forms a product which is, this is the product. So let us see how this product is formed and what is the mechanism. So basically, if I write the mechanism, so one aldehyde or one ketone, first, if it is CH3, so I can write it as CH2 and H. And since this reaction occurs in presence of a base, so this base, and since this hydrogen is acidic, so it goes along with the base. So this is sort of H plus and OH minus, so it gets released as H2O. So we get a carbon ion. So this CH3 becomes CH2 minus. Now this CH2 minus attacks on another starting compound that we have. So we started with the acetone, so another compound that we have is another molecule of ketone. So this negatively charged carbon attacks on this carbon, and this bond shifts in this way. So what is the structure that we have now is this one, and then I'm directly writing it as, and then this is the product. Now if I number them, so suppose if I start numbering them, so this is 1, 2, and this carbon is third, and this carbon is fourth one, and any one of them is fifth. The center one is fourth. So I can write this number here as 1, 2, 3. This one is fourth, and any one, either this or this, is 5. Okay. Now again, what happens? This next step will be, this H2O molecule which was eliminated at this step will again come back, and it will form, this O minus will become OH, and then we can write this one as like this. Again, if I write the number 1, 2, 3, this one is 4, and this one is 5. So this product is called, since we started with ketone, so this is called ketone. Okay, but it is very unstable, so it will undergo dehydration, means loss of water. So again, this is carbonyl carbon, so adjacent to this we have alpha H. This is alpha carbon, so this bond shift like this, and this OH gets eliminated. So finally we have alkene, which is of, this is the final product, means beta unsaturated, alpha beta unsaturated ketone. Okay, so I will tell you how to write directly, means we can directly write the product based on the whatever we have in the reactant. So again, I will take the same example, and I will tell you how to write the product directly. So if I start with again 2 moles of ketone like this. So the thing is, when you are writing the product, so one is going to be like this. Okay, so just look at the alpha H. So on both side we have alpha hydrogens. So write the second, since this is alpha H, so write another compound, because we are starting with 2 compounds. So write another compound adjacent to this alpha H, and then this is the trick, and then just remove these OH and join them by double bonds. So what we have is this compound, and then this is the product, and you can see this product and this one are exactly same. Okay, so since this compound is symmetrical, so either you can write alpha from this side or this side. Basically you can directly write the product. Okay, I will give you a few more examples on how to directly write a aldol product. So again, if I start with this compound, this is the compound, but since this carbon is carbonyl, so adjacent to this one is also alpha, and this one is also alpha. That means in this type of compound we have two alpha, so I will name it as alpha 1, alpha 2. So if I write the product with respect to alpha 1, then how can I write the product with respect to alpha 1? This is the compound, and since we are writing with respect to alpha 1, so I will write alpha 1 means alpha 1 hydrogen outside this in this way, and another compound is to be written like this is not oxygen, so another compound is to be written just means behind this one, so I will write it as, okay, so this we have like this. I will write this one, and now remove this OH and directly write the product. This is the first compound, this one, and then when we join these two, we can directly write it as like this, and this is the product for this reaction. This is the product. Okay, so but this is the final product because this carbon is alpha, this is beta with respect to this carbonyl compound, so this is called alpha beta unsaturated ketone. But when you have to write the aldol product, so this is the final product, means after dehydration, so when you have to write its aldol, so how can we write its aldol? Because aldol is formed when H2O is removed, so at the position of alpha write H, at the position of beta write OH. So how can we write the aldol product for this one is, so at the alpha we can write H, we don't write H in bond line, so it will be written as such, and then we have, sorry, this double bond is to be removed. Just a second, I will just write, since there is no double bond, so we don't need to write double bond because we are writing the aldol product. So at the alpha we can write H, but it is not necessary in bond line representation. Okay, so this is the product, but at beta we should write OH. This is the aldol product of this one, not aldol, basically ketone. Okay, so okay, fine. So we have written with respect to alpha 1, this is the compound. Now let us write with respect to alpha 2. If I write with respect to alpha 2, so again I will take the same compound which I started with. So since this is alpha 2, so if we have to write the product with respect to this, so I will remove this alpha 2 and write H here, and just write another, means the same product below this one. So I will write it as CO, and then like this, then remove this OH and join them by double bond. So what we have is, and then this is the double bond, should make it proper, this is the double bond that we have. So this is the alpha beta unsaturated product for alpha 2. Again, if I have to write its aldol form, aldol or ketone, whatever it is, so this is the carbonyl carbon with respect to this is the alpha position, this is the beta. So at alpha beta remove double bond, at alpha write H, at beta write OH. So the aldol product for this one will be, at alpha we can write H, at beta we have to write OH. So here we can write OH. So this is the aldol product. So this is for aldol reaction. Same we can write for cross aldol also. Okay, so let me give you just one example. Now cross aldol means in which either we have two different aldehyde or one aldehyde, one ketone. So I can take any example, like I take this aldehyde, this is CHO, CS3CHO, acetaldehyde, and then another one I can take is a ketone. Okay, so if I say write the aldol product or the final product for this compound, so basically you have to be very careful in this one is carbonyl, this one is also carbonyl. Basically we have two different carbonyl groups. So with respect to first compound, this compound, this is the alpha carbon, and with respect to second compound, we have two alpha. This one is also alpha, this one is also alpha. So now I will write alpha 1, alpha 2, alpha 3. So that means we have three different products. Okay, and now the rule says, means the general observation is here the major product is formed when ketone acts or attacks as a nucleophile. So basically when ketone acts as a nucleophile or it attacks as a nucleophile, then the major product is formed. A nucleophile, as a nucleophile on, you can also write on aldehyde. So basically ketone will attack on aldehyde, then major product is formed. So I'm not writing the minor one, I will directly write major products. So when ketone is, means this compound attacks on the aldehyde one, then we have two different product, because in ketone we have two different alpha H. So with respect to first one, if I write for alpha 2, so I'm directly writing the product. So for this one we can write, so since the alpha 2 is this hydrogen, and when it will attack on aldehyde, so this is the aldehyde molecule. So we can directly write the product, which is this is the final product. Now if you have to write its aldol, so again alpha beta, at alpha write hydrogen, at beta write OH. So this is the aldol product from alpha 2. Okay, now if I write from alpha 3, if I write the product of alpha 3, so this is again the ketone compound that we have, ketone. This is alpha 3, third carbon, third hydrogen. Again it will, when it attacks on aldehyde, so this is CS3CHO, write the product. So this will be COH, and these two are going to join with a double bond. This is the product. Now again if you write its aldol, so this is the carbonyl compound, this is alpha, this is beta. So at alpha you have to write H, at beta you have to write OH. So this is at alpha, you can write H, but I will skip it because it is not required. This is H, and here you can write OH. So this is the aldol product that we have. So this is the trick, how can we write direct products using any any reactant. Okay, second thing that I will discuss is about ozonolysis reaction. Again I will tell you one trick on how to write a product. Basically ozonolysis is the reaction of alkene which reacts with ozone to give two same or two different types of carbonyl compounds. So the rule that you have to remember, if alkene is symmetrical, then we get two identical products. If alkene is asymmetrical, we get two different products. So let us see how. First I will take a symmetrical alkene. So if I take a symmetrical alkene, basically ethene, so I will tell you how to write directly ozone, means product of ozonolysis. So whatever alkene you have, just divide the double bond in two fractions and put O on both sides. So basically what we get is 2 moles of CH2O, and CH2O is nothing but 2 moles of 2 moles of HCHO. So basically when ethene undergoes ozonolysis, the product is 2 moles of formaldehyde. That's it. Again I will take a symmetrical alkene. This is but 2ene. It undergoes ozonolysis. Again, divide this double bond and put oxygen on both sides. So what we have? CH3CHO, CH3CHO. Again, 2 moles of CH3CHO. So that's what I said. When alkene is symmetrical, we get two identical products. Now I will take a asymmetrical alkene. Asymmetrical. And then we will get two different products. So if I take asymmetrical alkene, asymmetrical means the alkene which is having different arrangement along the C double bond C. Again, trick is same. Just divide this double bond in two parts and put oxygen on both sides. So when it undergoes ozonolysis, we get CH3, CH3, CHO and CH2O. That means one compound is CH3, CHO. Another one is CH2O. That means HCHO. So see, one is acetaldehyde, another one is formaldehyde. So when we have asymmetrical alkene, we get two different products. Okay. So again, I can take one more example of any asymmetrical alkene. So this one is again but 1ene. So when it undergoes ozonolysis, so again this double bond divided in two parts, put O on both sides. So one product is CH3, CH2, CHO, and another one is CH2O. That means HCHO. So one is propanaldehyde, one is formaldehyde. So in asymmetrical alkene, we get two different products. Now the most important part is how to make ketone. How to make ketone using ozonolysis. How to make ketone using ozonolysis. So basically when we have to prepare ketone, we must have at least di-substituted alkene. So what does it mean? CH3, C, CH3, this is di-substituted, and then we can write CH2. So when this type of alkene means there's C double bond C, there should be a di-substitution, means it should have two side chains, means two chains of alkyl group. Okay, so when this undergoes ozonolysis, again same thing, put O on both sides. So one product is CH3 CO CH3. So one we have CH3 CO CH3, another one is again CH2, that means CHO. See, we get one ketone which is propanol and one aldehyde which is formaldehyde. So basically in order to get a ketone, this C double bond C, at least one carbon should have two side chains, means di-substitution of alkyl group. All right, so if I ask you write the ozonolysis final product of this alkene, so can we write? Yes, of course. So again, divide this alkene in two parts, put OO on both sides. So this is CH3 CO CH3. So we get one acetone and then CH3 CH2 CO CH3 CH3 CH2 CO CH3. So one is propanol, another one is but 2,1, and this is propanol. So in this way we can prepare any ketone or aldehyde using ozonolysis. Fine. Now reverse it. There are many questions which says the ozonolysis products are like if I write acetaldehyde and propanol. So any compound gives acetaldehyde and propanol upon ozonolysis. Now you have to write the alkene. So how can you write alkene using this product? So write down these two products, CH3 CHO, this is acetaldehyde, and propanone is CH3 CO CH3. So these are the two products. Write them in such a way that these double bonds are, means carbonyl groups are aligned head to head. Now just remove this OO and join them by double bond. Remove the C double bond O and join them by double bond. So CS3 CS3. This is the alkene, so we can rearrange this to get required alkene is CS3 C CS3 double bond CH3H. So this alkene upon ozonolysis gives one acetaldehyde and one propanone. So basically in this way you can write the product of ozonolysis, and with the product, with the help of product, you can write the required alkene as a reactant. Thank you.